This is a simple demonstration of the algorithm presented in Keywords-To-Sparql translation for RDF data search and exploration. It is a novel approach for keyword search on graph structured data and in particular temporal RDF graph, meaning RDF data that involve temporal properties. Our method, instead of providing answers directly from the RDF data graph, automatically generates a set of Sparql candidate queries that try to capture users' information needs as expressed by the keywords. We will demonstrate our method for the exploration of the Diana linked open data, a dataset that comes from the life science domain. The first query example is the word MI0001364, which is a hairpin microRNA identifier from the MIR-based database, and the word name. By typing the keywords into the text box and by pressing enter, the method generates a number of Sparql queries. In this example, the method produced 7 Sparql queries, as is also noted here. From left to right and from top to bottom, you can see all the generated queries ranked based on the selecting ranking function, in this case, the long and shortest path distance. You can select a ranking function or a combination of them by selecting the appropriate checkbox. In our framework, we provide 3 different ranking functions: A, the number of triple patterns, B, the average shortest path distance, and C, the longest shortest path distance. Note that the smaller the score of the ranking function for a given query, the higher its ranking position. The idea behind this is based on the assumption known as locality of information, meaning that the information required by the user can be modeled in terms of entities, properties, and literas which are closely related. To further assist the users, we provide also a natural language description of the generated Sparql query by incorporating the verbalization system Sparql2NL. In each query, you can see its natural language description and 2 action buttons. The top one reveals the generated Sparql query in a pop-up window, while the bottom one executes the generated Sparql query. When we execute a query, on the top of the screen we see its natural language description, along with the action button that reveals the Sparql query. On the bottom of the screen, there is a table that contains the retrieved results. Each column of the table corresponds to a variable from the Sparql query. In this case, H0 is hairpin entities, while V1 and V2 are string literals. By hitting back, we can return to the previous screen of the generated queries. The cross next to the input text box clears the screen. As we have already mentioned, our method is specifically designed to work with temporal RDF data. In order to support temporal exploration, our method is enriched with temporal operators that allow the user to explore data within predefined time ranges. We have defined 3 temporal operators: at, that can be used to retrieve data at a specific time point; before, that can be used to retrieve data before a specific time point; and after, that can be used to retrieve data after a specific time point. The temporal operators before and after can be used together to define a time window constraint. The temporal operators are used as follows: property, operator, value. Where property declares the desired property that a temporal operator will be applied its value constraint, operator declares the selected temporal operator, and value declares the desirable value constraint. For example, if we type year after 2006, we have used the temporal operator after, which will be applied to the property year. In this case, we will retrieve all papers entities published after 2006, since year property is only met with paper entities. For more details about the method, you can find in our paper Keywords-To-Sparql translation for RDF data search and exploration, presented in TPDL 2015.